Have you ever wondered why columns are so essential in construction? They're not just aesthetic elements that add grandeur to a structure. Columns are the backbone, the life support system of any building. They carry the load of the structure, distributing it evenly to the foundation, ensuring stability and safety. Without columns, our buildings would be like a deck of cards, susceptible to falling at the slightest disturbance. So, they're pretty important, right? Now let's delve into the different types of columns seen in construction. First off, columns can be classified based on their shape. Let's dive into square and rectangular columns first. They're the go-to choice for many contemporary buildings, and it's not just because they look good. These columns offer ease of construction, which is a significant factor in their widespread use. Now, while squares and rectangles have their place, don't overlook circular columns. A circular column is like the unsung hero of the construction world, often doing the heavy lifting in structures. Why, you ask? Well, it's all about stress distribution. With a circular column, the stress is evenly distributed, making it a sturdy choice for supporting hefty loads. So whether it's the chic appeal of a square column or the practical strength of a circular one, the shape of a column plays a crucial role in its function. Shape is just one way we categorize columns, but there's more to it than just geometry. Another way to classify columns is based on how they handle loads. Let's delve into this. First up, we have axially loaded columns. These workhorses carry the load directly down their long axis like a weightlifter hoisting a barbell straight overhead. They bear the brunt of the load in a vertical direction, which makes them a common sight in structures where the load path is straightforward and predictable. Now let's shift our focus to eccentrically loaded columns. These columns carry the load off-center, resulting in a bit of a balancing act. Imagine a waiter carrying a tray loaded with dishes. The weight isn't directly over his head but off to one side. This can cause bending or bowing in the column, adding an extra layer of complexity to their design. So, load handling is another crucial factor in column selection, but there's yet another way we differentiate them. Columns can also be classified based on their slenderness ratio and the material used in their construction. The slenderness ratio of a column, quite simply, is the ratio of its effective length to its least radius of gyration. This aspect of column design is critical as it influences the strength and stability of the structure. Let's consider short and long columns. Short columns, those with a lower slenderness ratio, are generally stronger and more stable. They primarily carry load in compression and are less prone to buckling. On the other hand, long columns, those with a higher slenderness ratio, may buckle under heavy loads. This is because they tend to bend or deflect more easily, leading to potential instability. Therefore, careful consideration must be given to the slenderness ratio when designing columns for a structure. Now, let's shift our focus to the materials used in column construction. Each material has its unique properties, advantages, and disadvantages. Reinforced concrete, for instance, is commonly used due to its high compressive strength and durability. It's also versatile, allowing for a variety of shapes and sizes. Next, we have steel columns. These are strong, durable, and capable of supporting heavy loads. They're also resistant to fire and pests. However, steel columns can be more expensive and require protective coatings to prevent corrosion. Timber columns offer a natural aesthetic and are relatively easy to work with. Yet, they are susceptible to pests and decay, and their load-bearing capacity is lower than that of steel or concrete. Brick columns are aesthetically pleasing and provide a traditional look. They are durable and fire-resistant but may not be suitable for heavy load-bearing structures. Lastly, stone columns like granite or marble are an excellent choice for an elegant and timeless aesthetic. While they're incredibly durable and strong, they can also be quite expensive and difficult to work with due to their weight. So, as you can see, the type of column chosen can greatly impact the structure's strength, stability, and appearance. We've covered a lot of ground today, haven't we? We dived into the fascinating world of columns, learning about their different shapes, loading types, slenderness ratios, and materials. We saw how square and rectangular columns differ from circular ones, how axially loaded columns contrast with eccentrically loaded ones, and how short columns compare with long ones. We also discussed the unique properties of reinforcement concrete, steel, timber, brick, and stone columns. Remember, the choice of column is not just about aesthetics, it's about engineering a safe and durable structure. Until next time, keep building.